Wow, those were some amazing yo-yo tricks. When Brett first started learning how to throw yo-yo, he had no concept of physics. Today, we're going to discuss the physics behind those cool yo-yo tricks. The main physics concept we're going to discuss today is momentum, both linear and angular momentum. We will also touch on a few other concepts, such as potential energy, kinetic energy, gyroscopic stability, and friction. I know what you're thinking, that's a lot of physics and equations. We won't go into all the physics equations today, just want everyone to be aware of some of the other physics involved in those tricks. As Brett gets ready to throw the yo-yo, he has potential energy stored in his arm, which gets transferred into kinetic energy once the throw of the yo-yo is completed. As the yo-yo is spinning, gyroscopic stability is acting upon the yo-yo. It keeps the yo-yo spinning in one direction, an axis is created and the yo-yo cannot turn on its side. The most important principle to yo-yoing is angular momentum. Angular momentum is the product of the moment of inertia and the angular velocity. What this basically means is that when the yo-yo is spinning, it picks up angular momentum, which keeps the yo-yo balanced to allow Brett to perform tricks. In order to calculate angular momentum, we need to first calculate linear momentum. The equation for linear momentum is P equals mass times velocity. Once linear momentum has been calculated, P will begin to calculate angular momentum. Angular momentum is L equals R times P. R is the radius of the string, P is linear momentum. In order to calculate the angular momentum of the yo-yo tricks, we have to measure the mass of the yo-yo, the radius of the string, and the velocity of the throw. The yo-yo's mass is 6.7 grams. The length of the string is 1.016 meters. This is the radius in the formula. We had to slow down the video and estimate the velocity of the throw. By slowing down the video, we determined it took approximately 1/20th of a second for the yo-yo to travel 1 meter. We now have all of the variables to calculate angular momentum. As you recall, angular momentum is L is equal to R times P. L is equal to 1.016 times 6.7 grams times 20 meters per second. The angular momentum of the yo-yo is 155.44 grams times mass squared per second in the rightward direction. At the end of the yo-yo tricks, Brett binds the yo-yo string, which causes friction on the string and makes the yo-yo ride up to his hand. Next time you see someone with a yo-yo, you will have a complete appreciation and understanding of the physics involved in completing yo-yo tricks. Angular momentum is the most important concept in yo-yo physics.